Hello friends, this video is to discuss about various processes by first law of thermodynamics. Various processes means adiabatic process, isothermal process, isochoric process, isobaric process, etc. So the governing equation, the first equation of first law of thermodynamics is H equal to U plus PV. H is specific enthalpy, U is specific internal energy, P is surrounding pressure, and V is specific volume. All quantities are specific quantities in small letters. If you want to see this derivation H equal to U plus PV, then refer to my video titled First Law of Thermodynamics. There you will get it. So we will proceed from this equation H equal to U plus PV. Let's differentiate both sides. dH equal to du plus pdv plus vdp. Now this quantity is called dq, heat transfer, which goes to increase internal energy and in expansion work, pressure energy, PdV work. So first let's consider isobaric process. Isobaric means pressure is constant. So dp term will be 0. So this term will be 0. So what we will get? dH equal to, let's put dq, dH equal to, completely we should put dH equal to du plus pdv, that much, dH equal to du plus pdv, or equal to dq, dH equal to dq. Means for isobaric process, just like our model, it is free expansion model. So heat transfer is equal to that enthalpy change. How much heat will be transferred, that much enthalpy will be changed. Second, isothermal process. Isothermal means temperature is constant. So here we have to write du in dt form. So first I am writing this. And look, this dq equal to du plus pdv. This is also first law of thermodynamics. So as for isobaric process or free expansion process, means surrounding pressure is constant. That is our practical problem. So in that case, dH equal to dq. So we could write this equation also. In that case, VDP will be 0. dq equal to du plus pdv, or dq equal to, this du is change in internal energy, it is cv plus pdv, where cv is specific heat at constant volume. So in isothermal process, this dt will be 0, so this term will be 0. So what we will get? dq equal to pdv. Okay. Next, adiabatic process. The objective of this video is to get you familiar with various processes and to discuss by first law of thermodynamics and solve the problems. Third is adiabatic. Adiabatic means heat transfer is 0, no heat transfer. So dq equal to du plus pdv. This is our governing equation. dq equal to du plus pdv. So this dq is 0. So du plus pdv equal to 0. That means du equal to minus pdv. So if suppose change of internal energy is given, let it be integrated. So delta u equal to integrate minus of integration of pdv. So that pdv we have to put from gas equations and solve. Any unknown quantity could be got. So in general, internal energy change is equal to minus of pdv. We will discuss so much about pdv work later on. Okay. Now fourth is isochoric process. Fourth, isochoric. Isochoric means constant volume process. So this dv will be 0. So dq equal to du or cv dt, cv dt plus pdv. So this dv term will be 0. So dq equal to cv dt or dq equal to du. So if volume is constant, so the heat transfer will go to increase the temperature of the body only, means to increase the internal energy, specific internal energy. So heat transfer will be equal to change of internal energy. So if internal energy is given or data for internal energy gain is given, suppose temperature is increased by this much and mass is this much, like that. So and cv of course will be given. So cv is specific heat at constant volume, so those will be given. So you could calculate internal energy gain. If you integrate it, so q equal to delta u. So delta U means U2 minus U1. So for that data will be given. So you could calculate this, and that will be equal to heat transfer. Suppose heat transfer is asked, isn't it? So many questions could be made by giving the numerical values. Okay, one more process is there, that is cyclic process. Last but not the least, it is fifth one, cyclic process. Cyclic process is like this. Suppose 1 to 2, then 2 to 1, 2 to 3, 3 to 4, and then 4 to 1. So this is called cyclic process, in which again same point will start. 1, then 2, then 3, then 4, then again 1 will be achieved. So cyclic process is to solve cyclic process problem is nothing but solving isothermal process, because every point is getting, suppose starting point is 1, so final point will be also 1. So there is no net change of temperature, so no net change of internal energy. So dq equal to du plus pdv. So du will be 0 in case of cyclic process, because points are repeating. So initial and final are same. So there will be no any net change of internal energy. So dq will be equal to pdv. Means all heat transfer will be equal to pdv work. So q, suppose q is asked, so integration of pdv, and this p will be given by the gas equation, pv equal to rt, mrt actually. So actually we took specific quantities, so per unit mass, so pv equal to rt. So p we could put here rt by v. So q will be equal to rt is constant, integration of 1 by v dv. So dv by equal to rt log v. Isn't it? So like this we will solve it. In any case, whenever pdv is there, so by integrating this will come, and this you have to substitute. So q equal to instead of rt you could write p1 v1 log v, है ना, 1 to 2, so log v2 by v1, or p2 v2 log v2 are equal to p2 v2 log v2 by v1, like this. So this is all about this video. We discussed about various processes and try to understand by first law of thermodynamics, and we also discussed various types of problems which could be made just by giving numerical values. So many problems we can make. Okay, thank you.